Today we're doing section 6.5, and that's the powers of complex numbers in polar form. So yesterday we multiplied and divided. Today we're going to be raising to a power. So we're going to introduce a theorem today, and the theorem is called DeMoivre's theorem. And this is introduced when you have a complex number being raised to a power. So the general formula would say z to the nth power, and when that happens, we raise our r to the nth power, and we multiply our angle by this n value. Again, if you need to pause the video to write this formula down, please feel free. You are going to be responsible for knowing these formulas when it comes time for a test. So we're going to take this problem and we're going to try our first example. So for the first example, the directions say find the quantity of 2 cosine of 20 degrees plus I sine of 20 degrees. And they want this raised to the 6th power. So again, obviously we don't want to sit there and multiply this out 6 times through because that's time consuming. Instead, we want to use the formula. So the formula says I'd have z to the 6th power. So I'll do 2 to the 6th power. And then I'll have cosine, and we'll be doing 6 times 20 degrees plus I sine of 6 times 20 degrees. So z to the 6th power, I would multiply 2 times out 6 times and I get 64. And this will become cosine of 120 degrees plus I sine of 120 degrees. And the directions want this written in rectangular form. So now I want you to put this in rectangular form. So I need to convert this. I know 120 is in quadrant 2. And if I wanted to convert this, remember I could multiply 120 by pi over 180. So I could figure out what this is in radians. The zeros cancel. 12 over 18 can be reduced by 6. So this becomes 2 pi over 3. So 2 pi over 3 is the angle that we're working with for 120 degrees. And 2 pi over 3 is negative 1/2 and a root 3 over 2 because I'm in quadrant 2. So I need to take that back into the problem. So cosine of 120 means cosine of 2 pi over 3, and that will be replaced with negative 1/2 plus I times sine of 120 will be root 3 over 2. I have common denominators here, so I can write this as negative 1 plus I root 3 all over 2. Again, the 64 is like a 64 over 1. So when I take 64 divided by 2 here, it will become 32 times negative 1 plus I root 3. And I would say the last thing that we can do is distribute this in. So our final answer is negative 32 plus 32I root 3. And I'm sorry that got a little messy. I wanted to try and condense this all in one screen. So notice we're just, again, kind of building off of these skills each day. The power part was the new part. The stuff in blue is new. The stuff in white is not new. That's what we did last week. So one more example. So they want you to find the quantity of 1 plus I raised to the 8th power using the DeMoivre's theorem, and they want you to write your answer in A plus BI form. So write answer in A plus BI form. So the problem is DeMoivre's theorem only applies to our complex numbers in polar form. So right now I have A and B, so I have to make it look like this whole Z R cosine of theta plus I sine of theta. So I have to find what R and theta are. So going back to what we did the first day, I'm going to do A squared plus B squared equals R squared. So 1 squared plus 1 squared equals R squared. 1 plus 1 is 2. So R will equal the square root of 2. So I found that much. Now I need to find theta. And to find theta, I do tangent of theta is equal to B over A. So 1 over 1 is 1. So I know tangent is 1 when my theta is pi over 4. And if I did a quick check, I know when I plot this coordinate, I'd be in quadrant 1. So pi over 4 is the angle I want. So now I need to take this information and I set it up. So Z equals root 2 cosine of a pi over 4 plus I sine of a pi over 4. So this is the equivalent version of this coordinate up here. But now I need to raise it to the 8th power. And the reason we need to use this formula is I don't want to sit there and multiply 1 plus I out 8 times, because that means you have to FOIL it and FOIL it and FOIL it, and it'll take very long. So here, I'm going to raise this whole thing to the 8th power. And you know from the last example that it's not incredibly difficult. Just follow the formula. So Z to the 8th power. I'm going to take my root 2 and raise this to the 8th power times cosine, and I multiply the angles, so I have 8 times pi over 4 plus I sine of 8 times pi over 4. And now I need to just kind of do some simplifying here. So root 2 times root 2 would give me 2, and then I have to do that 4 more times. So root 2 to the 8th power is actually going to be 16. My angle, 8 times pi over 4. So 8 over 1 times pi over 4 would become 8 pi over 4, which is 2 pi. So I get cosine of a 2 pi plus I sine of a 2 pi. And because the direction said they want this written in A plus BI form, that means I want it in rectangular form. So I got to write my coordinates down. So 2 pi is the same spot as 0. So that coordinate's 1, 0. So Z to the 8th power, I have 16. Cosine of a 2 pi is 1. Sine of 2 pi is 0. And then I distribute my 16. So Z to the 8th equals 16 plus 0i. So technically you don't really need to write the 0i. You could just say 16. You don't technically need that. But that's all for today. So we'll pick up with that for tomorrow.